Rolling motion. Rolling motion is a type of motion that combines rotation and translation of that object with respect to a surface, such that if ideal conditions exist, the two are in contact with each other without sliding. In layman's terms, a rotation motion plus a translation motion equals a rolling motion. Rolling motion is found in everyday life, such as the wheels of a car, skateboard wheels, ball bearings, soccer balls, basketballs, etc. A cool property of rolling motion is that it produces cycloids. A cycloid is a curve traced by a point on the rim of a circular wheel as the wheel rolls along a straight line without slipping. We set up a distance of 7 meters for a car to pass through at 15 miles per hour on cruise control. The tire of the car was marked with a brightly colored indicator that allowed for the tracking of the motion. Both the edge and the center of the tire was tracked and analyzed. We can see the video tracking matches the shape of the generated cycloid. There seems to be around 4 rotations within the 7 meters. Calculations. We want to find the angular velocity of the wheel, and to do that we can use these two equations. The first is experimental equation. We are going to compare its values to the one we get from the second equation. These are the measured values. The next thing we need to find is our linear velocity. We can find that by using the video analysis to track the center of the wheel of the same clip. Doing that, we find that the velocity is 5.108 meters per second, which is actually slightly slower than 15 miles per hour. The other way we can find the linear velocity is by using this equation. We get a velocity of 5.15 meters per second when we use the known values for distance and time. We can finally compare our two angular velocity equations. We get a value of 19.3 radians per second using the first equation and 20.3 radians per second from the second. That works out to a percent error value of 4.9. Possible errors could have been by friction, air resistance, etc. A few things that we learned were how to calculate angular velocity, how to draw cycloids, and the basics of rolling motion.